Okay. Okay. Hello. Hello everyone. It's really glad to be here to share. Yeah, today I'm not going to talk about the database, but I'm the founder of a database company that actually is why we use the brand companies. But today I'm going to talk about some of my own experience about building multi-agent collaborating platform. I think that would be more interesting. A little background about myself. My name's Ed. I would say a seasoned engineer. I started programming since early 90s. That really related to today my topic. So yeah, as a founder of the startup company, I still have like 50% of my time still writing code. So I'm super proud of that. Yeah, you can find me in quick. Okay. A little bit background about IDB. My marketing team forced me to do that. I will pretty quick. IDB is open source relational transactional database. It actually, you can consider it's a bigger and better Postgres or MySQL. So you can, but most of the time can be used in the most extreme and most mission critical scenarios like whole banking system or super extreme scale like billions of rows and millions of transactions per second, requiring something like that. So it's a very important mission critical database infrastructure. So it's widely used in a lot of companies. So basically every day, if you are logging into the internet, you basically maybe using IDB. Okay. So one of our famous customer and user is Databricks. Actually, IDB is supporting basically 100% of their metadata system. So every time you run the stuff job on Databricks, it actually supported part of this transaction supported by IDB. Okay. So this is the founder sharing, how Databricks love IDB. Okay. Sorry. Also, another customer is Atlassian, because I'm an engineer. I'm also super proud of that. Atlassian is actually a big IDB user supporting their SaaS platform. Okay. And today I actually want to talk about the AI agents, and I also, trying to provide the agent database platform on the cloud. I would say that 90% of our new cloud database instance is actually created by AI agent, not by a human being, not by the developer anymore. So one of the most famous customer of our agent database platform is actually Manus. Manus using IDB to build their full stack agent web application service recently. So it's actually supporting near millions of database cluster already. So it's crazy. But so like I said, today I'm not going to talk about database. I'm going to talk about the AI agent infra. As an engineer, I bet most of you are using coding agents like Cloud Code and Cursor every day. But the big problem of today's coding agent is, or most of the agents, is it's a sequential action. For example, like you ask a question, the agent will give you a feedback asking, hey, I'm going to do that. Do you approve? Basically 90% of in this case, it's like you can only approve, and get the result. But I think my vision is that in the future, we can, the agent will, it is a multi-agent architecture, so that you can just ask the agents or the team of agents to do some really complicated complicated tasks, and you can go to sleep, and the agent will collaborate and do their job, do their work, and maybe 3 days later, they will give you all you need. For example, I want my coding agent like, hey, can you help me to build a Linux kernel? something like Linux kernel, and I just go back to the go to sleep. And 3 days later, my agent team just submit their work. It's like a operating system kernel. But if we want to achieve this goal, we will found that the actual bottleneck is we don't have a collaborating platform for multiple agents. I'm saying like thousands of agents, or like even more. Okay. But because today the big problem is we have so many different type of service API technology. Today for example, like memory machine is a good product, but it exposed their own API is a new ecosystem, and it is. So I think today we have too many technologies, too many companies, too many things. So it is really hard for the AI agent to learn everything because it is the just have too many things. So I think today we are in a perfect place to share the idea I'm going to introduce in the following slides because we are in a computer history museum. And we have this problem, but I think this problem already solved in the ancient days. And also as a seasoned engineer, I think most of the time the good design is always the simple design. And what I don't say is that maybe we can use a file system as the unified and ultimate interface for all the agents to collaborating to share the memory or like using different patterns, but all built with the idea of the file system. Because I think file system is the most friendly interface for LLMs. And if we talk about the file system, why file system is so powerful? Because I started programming since early 19th. At that time, we don't even have GUI. We need to achieve everything by using shell scripts and pipeline to combine different tools together. But I think this idea is actually become very valuable in today's context. For example, this is the minimal and very powerful pattern for building the AI agent, just like this. For example, it's like if we store all the observation and context in the file, like for the name is observation, we cap this file and it show the content of this file and send it to large language model with the context of the memory in this file system in another directory. And the error thinking will output the content and send it to update into the short memory and also insert to the database to store the conversation history. And the action will send it to the execute in another file. So it is just like I said, the Unix pipeline and the shell script is a really good tool to combining different components together in the unified interface. Actually, someone have already used this idea in decades ago. Any of you know this operating system, Plan 9? Oh yeah, cool. I'm a big fan of Plan 9. I'm still using Plan 9, and it's really interesting operating system that in the Unix philosophy, there is a philosophy called everything is a file. But the Linux or most of the Unix system, they actually not following this principle very well. But Plan 9 is the this the embody this philosophy in a very extreme way. So yeah, I'm a big fan of this OS, but it is totally dead already. But in the early 90s, Plan 9 already have a very ambitious goal. They want to use a file system interface to collaborate like different computer together. Today I look at this architecture. It is like I'm a database developer. Recently in the database world, there's a philosophy called compute storage separation. This Plan 9 is already introduced this in decades ago. So yeah. And here's an example. If you want to browse to surf the internet in Plan 9, you have to do that. You need to catch the HTTP port to the special file and read the output from another file. So this is the example for to access the HTTP server. It's just like this. Okay. So I would say Linux VFS they borrowed this idea and created VFS. So if today you're delivering the new file system for Linux, basically you need to follow this API. But I would say this idea is actually comes from the Plan 9, I think. Okay, why it matters? I think the benefit of this methodology is very obvious. First, unified interface. Today, if you want to create a new tool for the LLM agent, I think if you read the recent blog posted by Anthropic, which shared the experience about context engineering for cloud code, you can find they found that using simple batch script like or batch tool like grep or using affecting the local file system, you actually have a really good quality compared to putting everything into the vector database. So raw data is actually better than embedding data. This is my 2 cents. I'm not quite understand why everyone is so see when we talk about the AI database, the first impression is vector database. But I think from my own experience, most of the time, the raw data is better than the turn all the data into the embedding data. So unified interface really important. The second thing is composition. Today we have so many tools, and every tool is really powerful, but you need to teach the AI to learn a lot of things about how to use that. So, but the file system API will solve this problem very elegant. And also, it's like for example, this is the example of composition. You can combine different tools in the very simple way. Okay. And also, today when we talk about the agent sandbox, the agent file system, most of the time we are just talking about local storage. But I think with the help of blob storage or the cloud database or the cloud storage, you can easily create the distributed environment with a file system API. Okay. And the most important thing is today's LLM is actually the excellent cell programmer. The file system just simply give them the ritual to script. So with this assumption, So I'm thinking, hey, today we have so many different tools. Why not? I create the abstract file system API like Plan9. So a couple of weeks ago, I started a new open source project called AGIS. And open source labs. You can say this, the AG means aggregated and also means agent file system. So I will share some example about how to use this file system to create a multiple agent collaboration framework. For example, I will share some building FS in my AGIS. The first is Q and SQL, S3 and Hubble. Okay, on the right side, there's some, I also create a simple cell for this file system. This cell included some building commands like, if you are Unix or Linux developer, it's like an everyday tool you're using. Okay, some examples. There's it's a pattern that the traditional file system doesn't support something like notification, or you want to notify another user, hey, there's something new. So that I created Q as a file system to make FS to support the pattern like the notify or sending message. So yeah. It's quite straightforward. So you can in this file system, you just simply create a new directory and create a directory and echo or cat file contents to your queues directory. And for the DQ operation, you can simply cat the queue name, the DQ file, and you can get the message. S3 FS is very important. You can launch your S3 bucket as a fast so that you can, and then you can use all the Unix files you like. Yeah, it's just simply mapping the S3 bucket into the FS. Well, this file is really it's SQL database as a FS. So because sometimes we still need to have some structured data, and I created this file system for this purpose. But you can see you can get some special file, and you can browse your database just like a hierarchy file system structure, and you can send a SQL query to the control file, and and you can use like a just like a SQL database.
Can you do select cost?
Sorry.
Can you do select cost?
Yes, of course. You can see this select, and you can also use insert. I also create some helper file like insert JSON. So my file system implementation will convert the JSON doc into the SQL statement. So yeah. And using all of this file system above, you can create some patterns. For example, I created NCB for this file system, and this is the pattern. I will not dive into the details, but it is quite straightforward. Just using the QFS for the message queue for different agents. And the second pattern is a task loop, so that you can easily launch hundreds of cloud code instances, and then this cloud code instance will watch their own directory, so that the coordinator send a new task to their queue, and the agent will receive the task. So that is another pattern. So using this pattern, you can easily create something like a wider research in just like several lines of a bash script. Okay. And the pattern 3, it is also a very common pattern in the distributed system, which is how to keep, the agent, how do you know the agent is still alive? So I created a file system called heartbeat FS. So if you are still alive, you can just touch your directory, the control file. And yeah, if you are not alive anymore, the file system will do the cleanup by itself. So that yeah, you just 4 lines of code. You can implement it, the heartbeat or keep alive the pattern. And the shared memory is quite straightforward. I don't even need to create another memory framework. I just use the memory as a hierarchy directory in the S3. Yeah. And yeah, it is the parallel research. It is the pattern that's using all the tools, building block I shared in the previous slides, so that you can easily create some, map reduce framework using this file system to do some large scale research, collaborating with multiple agents. And I don't know if I have time, but this. So I not only the building for FS, I also created proxy FS so that you can create multiple. You can use this proxy FS to chain up different AGFS together to have a federation. Yeah, it's quite funny.
Yeah, we're short on time.
Yeah, okay. And the last page, I have I created the very interesting FS called string FS, and it is using the rim buffer. You know what I mean? Yeah, to implement some very interesting use case like this. Okay, this is all I'm going to share. So yeah, this and this project is open source. Okay, thank you.